Hello, welcome back to the playlist of lectures on hypothesis testing. In this lecture, we will focus on the illustration of hypothesis testing using two real-time examples. The first example will take you through the necessary steps in deciding between H0 and HA, where the population characteristic is a population proportion of success. And the second example explains the steps to decide between H0 and HA, where the population characteristic is a population mean. Let's start with the first example. Let's get into the video. A survey was conducted to verify if people buying food products do read the nutritional facts published on the products before buying. An hypothesis testing is carried out to make a decision and arrive at a conclusion. The null and alternative hypothesis statements should be framed for this case. Suppose the population proportion of success pi, which is unknown, equals actual percentage of customers who read the nutritional facts before buying. It makes sense to make an initial assumption, that is initial claim, that not majority of the customers read the nutritional facts before buying. Note, reading is considered as success and not reading is failure. Suppose majority means more than 50% of the customers. We choose a null hypothesis H0, that is pi equals 0.5. Null hypothesis claims not more than 50% of the customers, that is not majority of the customers, read the nutritional facts before buying. The counterclaim, the alternative hypothesis is HA is pi is greater than 0.5. Alternative hypothesis claims more than 50% of the customers do read the nutritional facts before buying. The hypothesis test examines the null hypothesis H0, that is pi equals 0.5, against the alternative hypothesis HA, that is pi is greater than 0.5. Null hypothesis H0, that is pi equals 0.5, is rejected only when there is a sufficiently strong evidence that favors the alternative hypothesis HA, that is pi is greater than 0.5. The hypothesis test is carried out with a level of significance value alpha equal to 0.01. A sample of 1003 customers were randomly chosen and the question was asked to each one of them, do you read the nutritional facts before buying? And a response, I frequently read, is counted as a success, otherwise not. 582 out of 1003 responded with an answer, I frequently read. 582 successes out of 1003 customers. Sample proportion of success P equals number of successes divided by the sample size, which equals 582 divided by 1003, which in turn equals 0.58, that is 58%. P is the sample statistic, which is also the point estimate of the population proportion of success. P equals 0.58, that is more than half the size of the sample say, I frequently read. Is it just the chance variance of the hypothesized value? Or the deviation of the point estimate from the hypothesized value is statistically significant? In order to check the deviation statistically, we calculate the test statistic Z star from the point estimate P, calculate the P value, and compare the P value and alpha. In other words, statistically evaluate the deviation and make the decision between H0 and HA. The test statistic Z star equals P minus pi divided by sigma P, where P equals 0.58, pi equals hypothesized value, which is 0.5, and sigma P equals square root of pi multiplied by 1 minus pi divided by n, which equals square root of 0.5 multiplied by 1 minus 0.5 divided by 1003, which in turn equals 0.0158. Therefore, the test statistic Z star equals 0.58 minus 0.5 divided by 0.0158, which equals 5.06. The test statistic z star equals 5.06 means the test statistic is 5 standard deviations more than the hypothesized value 0.5, assuming the null hypothesis H0, that is pi equals 0.5, is true. But the conclusion is not made just on this fact. We still need to calculate the p-value. Since the point estimate p is greater than hypothesized value, p-value equals 1 minus probability of z taking a value less than z star, which equals 1 minus probability of z taking a value less than 5.06. Probability of z taking a value less than 5.06 approximately equals 1 from the z table. Probability of z taking a value less than 5.06 is beyond most of the standard z tables, and the maximum value captured in this z table equals 0.99998, which equals 1 for a z value 4.09. Therefore, p-value equals 1 minus probability of z taking a value less than 5.06, which equals 1 minus 1, which in turn equals 0. Given the hypothesis under test are H0, that is pi equals 0.5, and HA, pi is greater than 0.5, and chosen level of significance for the test alpha equals 0.01. The null hypothesis H0, that is pi equals 0.5, is rejected only if the evidence from the sample is strong enough. In other words, only if p-value is less than or equal to alpha. And since p-value equals 0 is far less than alpha equals 0.01, the evidence is indeed strong enough to reject the null hypothesis H0, that is pi equals 0.5. The hypothesis test confirms the probability of getting a sample statistic p as high as 0.58 is very low if H0 is true. It is very rare that the sample statistic p equals 0.58 is due to the variance in the sample distribution of p, and instead strongly supports the alternative hypothesis HA, that is pi is greater than 0.5. Therefore, the null hypothesis H0, that is pi equals 0.5, is rejected in favor of the alternative hypothesis HA, that is pi is greater than 0.5. The conclusion of the hypothesis testing is majority of the customers do read the nutritional facts before buying the products. That concludes example 1 on hypothesis testing involving decision on population proportion of success. Let's take example 2 that deals with a decision concerning a population mean. There is a growing concern amongst the employers on the time spent by employees on internet surfing and personal emails in a day, following a report that suggests most employees waste on an average more than 2 hours a day on such activities. CEO of an organization wants to determine if employees in an organization spend less time than the reported industry average. An hypothesis test is initiated to conclude if employees spend less time than the reported industry average. Since the available report claims that the time wasted is at least 120 minutes, that is 2 hours on an average per employee, the initial claim or the null hypothesis is H0, that is mu equals 120. Null hypothesis also implies that the time wasted on an average per employee is at least 120 minutes, can even be more but not less. Since the CEO wants to determine if the employees of an organization spends less time than the reported industry average, the hypothesis test should find sufficiently strong evidence that employees of this organization spend less time than the reported industry average. In other words, find a sufficiently strong evidence in order to reject the null hypothesis and favor the alternative hypothesis HA, that is mu is less than 120. The null and alternative hypothesis that would be tested therefore are H0, that is mu equals 120, and HA, that is mu is less than 120. An hypothesis test initiated by an independent firm contacted 10 employees randomly and asked about each one of them on the average time they spend on unofficial internet activities per day. They were promised anonymity during the exercise. Following is the data in minutes collected from each of the 10 randomly selected employees. Summary of the data is as follows. Sample size n equals 10. Sample mean, that is the point estimate x bar, equals 116.8. Sample standard deviation s equals 9.45. Suppose the value of alpha, that is the level of significance for the test chosen, is 0.05. Note that the population standard deviation is unknown and hence the sample standard deviation has to be used instead. Though the sample is randomly chosen, meaning the employees for this feedback were randomly picked, the sample size n equals 10, which is much smaller than 30, the sample mean distribution is not guaranteed to follow a normal distribution. And hence it is important to ensure that at least the population is normally distributed. The sample is plotted using the normality plot as shown besides. The plot is fairly linear, suggesting that it is plausible that the population is normally distributed. Techniques like examining the correlation between normal scores and the observed data and box plots can also be used to verify the normality in the population data. Refer lecture on Point Estimates and Confidence Interval Part 2. With a fairly normally distributed data and population standard deviation is unavailable and therefore sample standard deviation to be used instead, we proceed to calculate the t-statistic, t star, instead of z-statistic. T star equals x bar minus hypothesized value divided by s divided by square root of n, where s is the sample standard deviation, n is the sample size, and df is the degrees of freedom, which equals n minus 1. T star equals 116.8 minus 120 divided by 9.45 divided by square root of 10, which equals minus 1.07. P-value, the probability of getting a t-statistic as extreme as t star in this case, equals probability of t taking a value less than t star. P-value, the shaded area, equals probability of t taking a value less than minus 1.07, which approximately equals probability of t taking a value less than minus 1.1. Due to symmetry, probability of t taking a value less than minus 1.1 equals probability of t taking a value greater than 1.1. Therefore, p-value equals probability of t taking a value greater than 1.1. Probability of t taking a value greater than 1.1 equals the value from the t-statistic table corresponding to t-value 1.1 and df 9. That said, p-value equals 0.15. P-value 0.15 is greater than alpha value 0.05. Higher p-values suggest that sample mean, that is the point estimate x bar, which is 116.8, is not far enough from the hypothesized value. And the deviation of the point estimate x bar 116.8 from the hypothesized value 120 is statistically seen as a chance variant of the population mean that is plausibly closer to the hypothesized value 120. Conclusion from the hypothesis test is the evidence from the sample data is not sufficiently strong enough to conclude that the average time spent by each employee on internet surfing and personal emails is less than 2 hours. Therefore, null hypothesis H0, that is mu equals 120, is not rejected. That concludes example 2 and brings us to the end of the lecture on illustration of hypothesis testing using two real-time examples, one involving a population proportion of success and the other involving a population mean. We discussed each step in the hypothesis testing process in detail, explained the contextual meaning at each step, and arrived at the conclusion. See you back with the last lecture on power of the hypothesis test and evaluation of type 2 error, that is beta. Bye till then.